In this video, we'll be covering Chapter 11, Section 3 on combinations. So if you remember, 11.2 permutations meant that the order had to be perfect. So some of the rules for permutation are very similar to combination. For permutation, we selected items from the same group. Well, that's true for this case. No item was used more than once. That's also true here. The major difference is that for permutation, the order made a difference and it had to be perfect. Combinations is very similar, except the order doesn't make a difference. And I have that here. Order does not make a difference. So let's go back to that example that we used last time. Remember here, it said a perfect order, and we used the three people at first, John, David, and Mary. So now let's say for combination, what we're going to say is instead of there being specific roles, we're just going to have them in a team. Okay? So when they're in a team and there's no roles or offices or positions, then it doesn't matter who comes in first, second, or third. So if I say John, David, and Mary, or Mary, John, David, or David, Mary, John, or John, Mary, David, or Mary, David, John. The last one was David, John, Mary. Now in this particular case, it doesn't matter who came in first, second, or third because the order does not matter. There's no roles, offices, or positions that these specific people are going to be in. All of this would be considered one group. So when you have three positions and you need to pick three people, there's only one way you can do that, and that's using combinations. So let's look at the calculator. So if we have three people to choose from, I'm going to go ahead and pick 3. And then now I'm going to go over to the combination where order doesn't matter. And I'm going to choose 3 people. There's only one way to do that. So all of these orders is considered one because they don't have any specific role to play. Okay. If we add on 2 more, we can determine how many roles it was. If you remember, there was going to be 60 in this particular case. So let's try it on this side. Let's do 5, choose 3. Well, now there's only 10 ways that we can choose 3 people from this list. So if there's 10 different combinations, if we choose 3 people out of this group of 5, let's see what those combinations could be. Well, we could have John, David, Mary. That would be considered one group. It could be John, David, Eric. That's a completely different group. John, David, Lisa. It could be John, Mary, Eric, John, Mary, or Lisa. Notice I haven't repeated any of these. It could be John, Eric, David, but we already have that one here. John, Eric, Mary. That's located here. John, Lisa, Eric. That's not listed. So John, Lisa, Eric. Okay, so John has been completely used now. So now we're down to these 4. where John is not going to be in the mix. We could have David, Mary, Eric. We could have David, Mary, Lisa, David, Eric, Lisa. And that gets us to 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we've used up David completely. So the last combination would be Mary, Eric, and Lisa. Eric and Lisa. That's the last three. So if I look at my list, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have exactly 10 different combinations. Now let's go ahead and determine if the given scenario is a permutation where order matters or a combination where order does not matter. How many ways can you select 6 free DVDs from a list of 200? Well, in this case, because we're not putting the DVDs in a specific order, this is going to be a combination. Part B. In a race in which there are 50 runners, no ties, in how many ways can the first 3 finishers come in? Well, because you have first, second, and third place, it makes a difference if you come in first, second, or third. So here it's going to be order matters, and that means permutation. For part C, it says choosing 3 scoops of ice cream from 31 different flavors. How many bowls of ice cream can be made? Well, here if I put vanilla first, strawberry second, and vanilla third, I still have 2 scoops of vanilla and 1 scoop of strawberry. So it really wouldn't matter if I put 2 scoops of vanilla first and then the strawberry on top. So because the order doesn't matter, it has to be a combination. So on this page, it's showing you the actual mathematical equation for combination. It's very, very similar to the permutation, except this time here, we're also including the r factorial. Remember that explanation marks means factorial. Number 2, you volunteer to pet sit for your friend who has 7 different animals. How many different pet combinations are possible if you take 3 of the 7 pets? Well, here again, it's not in a specific order. We're not putting the animals in first, second, and third place. So combination is going to be used because the order does not matter. So remember, n is always going to be the larger number, in this case 7, and r is how many you're actually taking, and in this case you're taking 3. You always put n first, which in this case is 7, PRB, choose the combination, and then choose 3, which means you're going to have 35 different combinations if you take 3 out of the 7 pets. C. How many different 4-card hands can be dealt in a deck that has 16 different cards? Well, again here, this is going to be a combination because let's say if I get these 4 cards, does it matter if I'm given the king first or the 2 second? No, you could actually get it in this order, but you have the same number of cards. So where the order doesn't matter because I can physically change the order myself, it doesn't matter, it's going to be a combination. So here my n is going to be 16 because I have 16 different cards and I'm only choosing 4 of them. So again, if you put in your calculator 16, PRB, choose 4, you're going to get 1,820 different combinations. So number 4 is a slightly different problem. It says a zoo has 6 male bears and 7 female bears. 2 of the male bears and 3 male bears are going to be selected for an animal exchange program. How many possible 5-bear collections are possible? Well, here again, the order doesn't matter because it doesn't it's not like we're putting the bears in first, second, or third place, so order does not matter. We're going to be using the combination. However, since we're using a specific number of females and taking a specific number of males, we're going to be using the combination twice, one for the females and one for the males. So out of the females, we have seven female bears, but we're only choosing 3 females to go on the exchange program. For the males, we have 6 male bears to choose from, but only 2 are being selected to go. So we're going to do this twice. We're going to do 7 choose 3, which is 35, similar to the problem we did here. And then we're going to do 6 choose 2, and that comes out with 15. Now, this is where it gets a little tricky, because we have 35 combinations to choose the females, we have 15 combinations to choose the males. How many combinations altogether? This is where you go back to that 11.1, the counting principle, and we multiply our choices. So we're going to multiply 35 times 15, which gets us 525. In this particular case here, we're using multiple different techniques to find our total combinations. We're using a combination and we're using our counting principle. That concludes 11.3 over combinations, but don't despair. There is some practice problems on MyMathLab when we have to deal with using multiple different techniques to find our answer, and I'll be going over that now. So I'm going to go ahead and show you where you can practice the problems like we just did with the elephants. Okay, when you're in your MyMathLab page, you're going to go ahead and select on the MyMathLab tab. Scroll down to the 4th option, which is the MyMathLab Multimedia Library. Once you get here, go ahead and click on Chapter 11, and we're going to go ahead and select all for everything in this chapter. Okay, so all of our animations are located here. We've already practiced the fundamental counting principle tree diagram, and this one we're going to do now is the combining the counting methods. So this is very similar to those problems that we did with the elephants. So go ahead and click on that option. Okay, let's go ahead and practice. Assume that you and 11 of your friends have formed a company called Net Media, which is an internet music and video provider. The committee consists of a president, a vice president, and 5 member executive boards which will govern the company. How many different ways can this committee be formed? Okay, so this is going to be where we're going to go ahead and choose our N. Now, be careful here because N in this case is going to be 12. It says that you and 11 of your friends. So that means there's a total of 12 people who can be chosen from. The next part says that the committee consists of a president and a vice president. So here we have a president and a vice president. If you notice, we have positions that matter. So here we're going to be using permutation. N is still going to be 12, and in this case we are going to use an R of 2 because there's only 2 positions. Right? In the other part, it says that there is also a 5-member executive board. So over here we have a 5-board committee. So in this case, these people do not have specific roles, so we will be using a combination here. And R would be equal to 5. Now the very first thing we want to do is we always want to choose our president and our vice president first. We're going to have NPR, which is 12P2, and let's find out what that equals in our calculator. So 12 PRB, choose the permutation 2. That comes out to 132 unique combinations. Over here, we can say now that we've had 2 positions filled, our n is no longer 12, but here our n is now going to be 10 because 2 positions have been filled. Let's go ahead and solve for this. We're going to do NCR, which is 10, choose 5. So let's go ahead and do this one. 10, PRB, choose 5. In this case, there's 252 different combinations if we choose 5 people out of the remaining 10 that are left. So how do I figure out how many different combinations? Well, what we're going to do here is just multiply these two numbers. So 132 times 252 is going to equal 33,264. Now the difference about this one is you don't have to enter it. So what you can do here is go ahead and press start, and it will walk you through the entire process of how to find out the number of different ways this can happen. As you can see here at the bottom, it shows you can have 33,264 ways to choose the committee, which is exactly what you have here. So this particular one doesn't have you answer the questions, it just explains to you how you can find it, and then you can practice on your own and compare it to the answers that you have. Right? Once you're done, just go ahead and press next, and it will give you a new problem to try. Okay, let me know if you have any questions.